Hi and welcome to this screencast. Today I'm going to talk about how you can use indexing to extract elements from a vector, how you can extract a single element, multiple elements, and how you can use logical indexing. And I'm also going to tell you about how you can use indexing to modify elements in a vector. Now first let me create a vector. I'll call it x, and I'll put in some numbers like this, and we can see the vector gets created with these numbers. Now if I want to extract, for example, the third element of the vector, I can simply use an index. That's a number in square brackets. So I can type x of 3, and that will give me the third number on the list. That's 2.3. Now of course I can also put this index into a separate variable. I could call that index, for example. So I can create a variable index, set that equal to 3, and then I can simply type x of index like this. That will give me the third number on the list or on the vector. Now if I want to extract more than one element, for example number 1, number 3 and number 5, I can simply index x using a vector. So I can type x of and then put in a vector with the numbers 1, 3 and 5, for example. And that will give me the first, the third and the fifth element of the vector. So this one, that one and that one. Again, of course, I can put that into a separate variable, index, for example. Index equals to the vector 1, 3, 5, and then I can type x of index. Now a different way of indexing is to use a logical vector. That's a vector that contains only true or false values. So if I want to use logical indexing, I need to index using a vector of the same length as x. For each element in x, it needs to contain the value true or false, and then it will extract the ones where the value is true. So for example, I could type x of, and now I'll create my vector, true, false, true, false, true, false, 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 for example. So this would extract element number 1, not number 2, number 3, not number 4, number 5, not number 6, 7 or 8. And we see it returns the correct values like this. Again, like before, I could put in this logical vector in a separate variable. So I could type index equals this vector. Now we see it gets created up here, and now I can use that to index into x simply by typing x of index as before. Now the same techniques that we use to index and extract values from a vector can also be used to modify elements inside the vector. So to show this, I'll first create a copy of my value of my vector x and call the copy y. Now for example, if I want to change the third element in y, I can simply write y of 3, and I can use this on the left side of an assignment. For example, to say y of 3 is set equal to 77. So doing that, the third value in y will be changed to 77. Now let me reset y. I can also change multiple elements at the same time. Just like before, I can use a vector to index y. For example, I can get the first, third and fifth element, and I can change them all to, again, 77, for example. So running this code, the first, third and fifth element will be set to 77. Now let me reset y again. I can also set multiple items or multiple values to different values. So again, I can say y of index 1, 3 and 5, and now I can use a vector on the right side of the assignment. So it must be a vector of the same length as the number of indices that we get. So I can set those to, for example, 20, 40 and 60. And now we see the first, third and fifth element are set to 20, 40 and 60. Now let me reset again. As you probably know, we can test whether a value of y is greater than some number simply by typing y is greater than, for example, 5. And doing that will return a logical vector, a vector that contains the value true or false for every item in y. So in this case, the first one is false because the first number is not greater than 5. The next one is true because it is greater, and so on. And as you just learned, these types of logical vectors can also be used to index into the vector y. So for example, if I want to extract all the values of y that are greater than 5, I can simply type y where y is greater than 5, like this. So I use this logical vector to index y. And this will return all the values of y that are greater than 5. So there are 4 of these values. And I can also use this on the left side of an assignment. So if I write like this, if I set it equal to 77, then all the values in y that are currently greater than 5 will be changed to 77. And so we can see what happens here. All these values that are greater than 5 or used to be greater than 5 are now changed to 77. Logical indexing is a very powerful method that is quite important to master. But sometimes it can be a little confusing with these logical vectors. So if I write x greater than 5, for example, as you know, you will get a logical vector that indicates which of the values inside x that are greater than 5. Sometimes it can be quite useful to convert this into a normal vector of index values, and that's quite easy to do using the which function. So I can type which x greater than 5, and now I'll get a normal vector that says that index number 2, 4, 6, and 8 of x is greater than 5.